Okay, so I think it's good to now begin. We are all around here. Oh, Manish, lead us in prayer, please.
Yeah, thanks so much for today. Please help us as we dive into today's lessons. Help us to understand and remember what we've learned and be ready for the test. I pray in Jesus' name. Amen.
Amen. Yeah, he is expecting a quiz. I know because we will have a quiz on Tuesday. All right. We will finish the chapter today and start with a new chapter. So at least after that chapter of what's this, equations and inequalities, then we'll have a short quiz on that one. All right. So
Two.
yeah, I have given feedback on your homework 6 on what is this? Your linear models and applications. So, well, in the quiz, I will be giving very similar questions. Uh, what is important is at least you have the idea on what you should do whenever you have some real world
Yes.
problems that need equations, being able to translate uh,
Right.
verbal descriptions to algebraic equations. Okay. All right. So today we started, of course, I introduced the quadratic formula last meeting. And we got it, of course, from our completing the squares. And so, as I mentioned, especially when our problems would already be real world, where it involves fractions or decimals, then the best way is to use the quadratic formula. So let us just have some examples on how to solve a quadratic equation using the quadratic formula. All right. So the equation, the quadratic formula is minus b plus or minus the square root of b squared minus 4ac over 2a. And of course, we said that this came from, let me write, this came from the general form of the equation of a quadratic equation, which is ax squared plus bx plus c is equal to 0. So that when you see a quadratic equation, you know that the coefficient of x squared is a, the coefficient of x is b, and your constant is c. So that's the only thing you have to do to identify the values of a, your b, and your c. So in that simple equation, x squared minus 3x minus 5 is equal to 0. So our a there is 1, right? So whenever there's no number, it's understood that it's a 1. And for your b, it is minus 3. And of course, your c is minus 5. Okay, sorry for that number. Then we just substitute. So from that quadratic formula, we say minus b. But our b is our b is minus, okay, let me erase that. Minus 3, okay? Tell you. Minus 3 plus or minus the square root of your b is of course minus 3. We square that. Minus 4. Your a is 1. Your c is minus 5. All over. So take note that the 2a is the denominator of the whole quantity up there. So times 2 times 1. So you can do, if you're used to this, you immediately can put in, that minus 3 squared is 9 and so on. But let us just do this step by step. So you now say x is equal to minus 3 is 3 plus or minus the square root of 9 plus 20, right? Hmm. 4 times -1 times -5 is 20, divided by 2 times 1, which is equal to 2. Yeah, because looking at x squared minus 3x minus 5, you know that one you really cannot do factoring there, because the only factors of 5 is 5 and 1, 5 and -1. So you cannot get a minus 3x for any of the factors of 5 as -1 and 5, or -5 and 1. All right, so we'll now have x is equal to 3 plus or minus the square root of 29 all over 2. And that will now be your final answer, that unless this is a real world where you have to extract the square root of 29. So there are now two answers there. You know that a quadratic equation will have two answers. The first one will now be 3 plus the square root of 29 all over 2, sorry. And the second answer will be a 3 minus the square root of 29 over 2. Okay. So it's plus or minus. So if you are able to extract the root of 29, then you now can really do the simplifying. You add 3 plus that square root divided by your 2a, and then you subtract. So that's now at least an illustration on how to use quadratic formula. All right, so let's try one for you, then we'll have some real world applications. Okay, so this one. All right, I hope it doesn't, okay. 3x squared plus 4x minus 15 is equal to 0. Use the quadratic equation formula to solve the quadratic equation. Answers?
In progress.
Okay.
16. 16 times 6. Minus 4 plus minus.
What did you get? What did you get, Manish?
Yeah,
Did you get
-4
-4
plus -4 square root of 6 divided by 6. I mean, over 6.
Okay.
Correct.
Oh, I just want to know, do others agree to that answer?
I'm getting there. What is root 196? What is root 196?
There's not a perfect root on that.
Yes, there is. There's 14.
Really? 14 times 14
What is root 196?
is 96.
14. Really?
Are you sure?
The square. You have a square root of 196?
Wait. Calculator.
And what's the square root of 196?
Yes.
Yeah, so it's
Oh,
-4
yeah. Yes.
plus.
Same, I told you.
Oh no, it's gonna be 14, right?
Yes.
So
I have
Yes,
x equals
14.
3 and x equals -3.
You okay? And the other one is?
X equals -3.
Yeah, there should be two answers.
X equals 5/3 and x
Mhm.
3.
Equals to -3. All right, try doing that. Those should be the answers. X 5 is equal to 5/3, which you will obtain when you will add 14. And then when you subtract 14, then you have -3. Try again so that you will. Yes. So I think it's just you were able to put in all those values. And so, of course, your A is 3, your B is 4, your C is -15. All right. And I think you were able to. So it's now -4 plus or minus the square root of 16 plus 4 times 3 times -15 will be a plus, okay? And so multiplying, I think you got 180. All
What did you
over
get?
2 times 6. So therefore, you now have x is equal to -4 plus or minus the square root of 196 over 2 times 3. Sorry for that. I already immediately multiplied and then okay. This should be a 3. My mind is
-4 plus 14.
okay, yes. So this is 3. So that will now be 6. And so the square root of 196 is 14. So you'll now have x is equal to -4 plus or minus 14 over 6. Is that okay?
Yeah.
So therefore, you'll now have your x will be, one of them is -4 plus 14 over 6.
Yeah,
You
-4.
have 10 over 6, which is 5 over 3. Of course, the other one is x is equal to -4 minus 14 over 6. And -4 minus 14 is -18 over 6, which will give you -3. So you'll have two answers, -3 and 5 over 3. Did you see where you went wrong?
Yeah.
Okay. So here looks like we need some kind of calculator if you could not remember the squares. But if you are able to remember the squares from 1 to 20, then that would be easy. But there's no harm in using the calculator to make sure that your answer is correct.
You can also plug in numbers and see if it equals 0.
Okay.
10.
Yeah, it's also good to, if you want to check, yeah, you can check to make sure that your answers are correct. So you substitute instead of x. If you say is minus 3 correct, then substitute. All right. So you say 3 times negative 3 squared is 27. Okay. And then 4 times negative 3 is 12. And so 27, 4 times 12, 3 times 9. Okay. And so 12 minus 12 and minus 15 is minus 27 plus 27 is 0. So just to check that your answer is, or your answers are correct.
You get minus 18 over 6.
Yeah, there's not.
And 18 over 6 is 3. Okay? 18 divided by 6 is 3.
I left it 18 over 6.
Oh, all right. So if you're able to divide, then do that. Or you can simplify like 10 over 6. Make it 5 over 3 because there's a common factor between 10 and 6, which is a 2. So divide 10 by 2, divide 6 by 2. So you get 5 over 3. Try your very best that your final answer is the most simple answer. Okay. So I just want to, I think plugging in, you have no problem. It's just be very careful in, doing multiplication, looking at signs, and take good care of making sure that you are putting in the right values. And of course, if you could not do the mental math in calculating, then just choose the calculator. Okay, so now, as I was saying, there are, if you are able to do factoring, then you do factoring. If you are able to do square root property because that's what the problem requires, then do that because that's much easier to do. But otherwise, if you are not sure what to do, then use the quadratic formula. If you are also excited about it, then you use completing the squares. Okay. So anyway, completing the squares and quadratic formula, they are just very much related because the quadratic formula we obtain from completing the squares. Let's now have this one application, maybe, and then another one that you can do as an exercise. It says a formula for the normal systolic blood pressure for a man age A, okay? Measured in mmHg is given as P is equal to 0.006 A squared minus 0.02 A plus 120. Find the age of the nearest chair of a man whose normal blood pressure measures 125 mmHg. Of course, they say that your normal blood pressure would depend on your age. So the older, like being an old person, I may have a different normal blood pressure than the younger ones. And so they made this equation, P is equal to 0.006 A squared minus 0.02 A plus 120. All right. So your P is the pressure, the blood pressure. Okay, that P. That is the systolic blood pressure. So we want to transform this P is equal to 0.006 A squared minus 0.02 A plus 120 as a quadratic equation. So we are now saying the blood pressure of that person is 125 mmHg. So we want to know the age of that person. All right. There's actually a range, but we'll just use one age in a way. So what we do is we substitute our P is 125 is equal to 0.006 A squared minus 0.02 A plus 120. Okay, so that P equals, that's not yet the quadratic equation that we'll be using. We're plugging in the pressure of 125. So therefore, our final quadratic equation will now be 0.006 A squared, because I transfer 125 to the other side, all right? Minus 0.02 A plus 120 minus 125 is equal to 0. So it becomes ax squared plus bx plus c. So our final quadratic form equation will now be 0.006a squared minus 0.02a minus 5 is equal to 0. So that's our quadratic equation. And from there, we will now say our A is 0.006, our B is 0.02, and our C is negative 0.02, and our C is negative 5. With this, kindly plug this into the quadratic formula and let us see what will be the age of that person. So instead of X, you say A equals to, right? Kindly do that. And then use your calculator and give me the value to the nearest year. Mm-hmm.
Next.
You got an answer? So you ended up to say 0.02 plus or minus after squaring the 0.02 and minus 4 times 0.006 times minus 5, you got a 0.124?
No,
So it's 0.02 squared. Where is my calculator? Let me check. What did you get?
I got 0.
The one that at the one inside. Yeah, so 0.02 squared is 0.0004, right?
Yes.
And then 4 times 0.006 times 5 is 0.12.
Then
So let me just erase so that let's see how. Okay, so here, all right. So negative 0.02 squared is 0.004.
0.
0004. Okay, there are 3 zeros, right?
Zeros.
0.02 times 0.02.
0.0000604, I mean.
Okay, yes. There are 3 zeros and a 4.
Yes.
Plus your 0.4 times 0.006 times 5, that will be a plus because it's a minus minus.
0.12.
Yes. Okay.
Hmm?
Yeah, 0.12. So it's 0.120. Okay. So we add plus 0.004. 0.12 plus 0.0004. Okay, so it's 0.1204. I put 1.124. Okay, all over 2 times 0.006 is 0.012.
Mm-hmm.
Yes. Okay. So what's the square root of 0.1204?
Up
You
the
round it off to just maybe 3 decimal places. Okay. So you
Point.
have your final thing there is 0.02 plus or minus the square root of 0.1204 over 0.012. And the square root of 0.1204 is what? Now use your calculator to do that. Square root of 0.1204 square root. Point 347. Yeah, I just want to round that off to the nearest thousands. Did you get a 0.347 over 0.012? Is that okay? Now, you now have a 0.02. So there are, if it were not a real world problem, then you will have two answers. But now that this is real world, you would realize that if you subtract 0.02, 0.347 from 0.02, you'll get a negative answer. So in this situation, you only have to use the answer that is relevant, okay, in relation to the problem. So you now have your aids to be just the positive one. So 0.02 plus 0.347, because if you subtract, you get a negative answer. So adding 0.02 plus 0.347 and divide that by 0.012, you get your answer to be the nearest year. You get it as 30.58. So round it off. What's the question there?
I got 28912.
For what?
No, 347 plus 0.02 was 37.
Okay, and divide by 0.02 and divide that by 0.012. After
28.
adding, okay? So you say 0.02 plus 0.347 gives you 0.367, right?
Yes.
But divide that by 0.012, which is your
0.67.
denominator, okay?
I didn't get 0.67.
But you
I
did.
got 347.02.
Which one?
Where did you get the 367?
33.
0.02 plus 0.347. You add the two.
Oh.
So we had a 0.02 plus or minus the square root of 0.1204. We extracted the root of 0.1204 and it's 0.347. We rounded it off 3 decimal places. And we said that we do not use the minus because you'll get a negative answer. So you'll be using the plus. So it's 0.02 plus your square root of 0.1204, which is 0.347, and divide by your 0.012. Okay.
3.058.
30 point. I
All
got
right.
30.
So divide 0.367 by 0.012, you get 30.5 something.
Divide by
Right.
100.
I'm using common sense.
30.6.
I'm lost in my mind.
Oh, what do you mean by you are using common sense?
No, it's not 3. So I was
Yeah,
joking.
it's something like about 30. Oh, yeah, you can because have a 36, 7 and divide by something like that. All right. But anyway, yeah, you can do that too, but we are saying it's 30.58333. But
One five.
then we want the answer to be the nearest year. And so okay, so it's now 30.583 and so on. So your final answer now will just be, how old will the person be?
31 years old.
31.
31 years of age. All right. So that person will be 31 years of age. So actually there is for a 30 to 40, they have a range, all right? So some will be 125, others will be 130 and kind of thing. Okay, so your answer for that is that a man who is 31 years old will have a normal blood pressure of 125 mmHg. So any question on that? Okay. So
No.
yes, that's
Mhm.
fine.
Yes.
Yeah. All right. This one. Yeah, I have some health related problems here that we are working on. So this one is an epidemiological study of the spread of a certain influenza strain that hit a small school population. So they are talking of the number of days where the flu had spread in that school. And so they found a model where the days would be between 1 to 6, 1 to 6 days. And they found that your P, which is the number of students who contracted the flu, days after it broke out, they made this model using the data from the first day to the 6th day. That's why they say T should be just between 1 to 6. So they are now asking, find the day that 160 students had the flu. What at which day, all right, had the students, 160 students had the flu. Okay, so we'll have to make our quadratic equation. So our P is?
160.
Yes, equals minus T squared plus 13T plus 130. All right. Simplify this, make it as a quadratic equation, and solve for T. Okay, do that.
And T and plus are easy to get confused.
Really?
At least in my handwriting.
Not for me. I was confused by P comma. I thought that's P1.
Which is,
Just when I'm writing it down.
okay. 160 equals minus T squared plus 13T plus 130.
So A is 1. B is
So my suggestion is make your the sign of your T squared positive, so you don't get a little, we want our sign of T squared to be positive. So that your final equation, did you have that as t squared minus 13t? So transfer to the other side. Plus 1 plus 30 equal to 0, so that I want to make sure that you are plugging in the correct. You can also have the t squared retain it to be minus, but I just feel like a better quadratic equation is when the coefficient of your the square is a positive. So to transfer t squared to the other side, then minus 13t, 160 minus 130 is 160. What is 30? Okay. So go ahead and solve.
Yeah, I got 10 and 3.
All right. So will you have two answers?
Yeah, no, this have a perfect square.
But
Really.
look at the way the problem is saying. Your t should just be between 1 to 6.
Oh, yes. So the answer is
Oh,
3.
yes. So it's also important to look at the restrictions in the problem so that you'll just give the answer that is required.
Oh, so 3 days later,
Mm.
160 and the proof.
So everyone got 10 and 3?
We're working on getting it.
All right. Yes, you will be able to get it.
Theoretically, 10 is correct.
Huh?
In theory, on paper,
Yes, yes, in theory. But because this is the real world, then give the answer that is required. And so it says, you only want your t between 1 to 6. Because usually after 6 days, then you will have your number of students already lowered because, they will have vaccines, so students will not anymore be contracting the virus. So that's why they're restricting that from 1 to 6 only, because after 6 days, there will already be a different model. So this model is only with day 1 to day 6.
Oh, right, it's 30.
No, you know what? My problem with math,
Mm.
what I'm struggling with is critical thinking. So you can be fast in calculation, but if you don't understand the problem and what must be used, you must say
That's true.
is this algebra is basically subtracting and it's arithmetic, basically, which everyone is good at.
So in the end, after plugging and doing all the the things there, where you now have a minus 13, then minus 13 squared, and then 4 times 1 times 30, you got 169 minus 120, then therefore you get a square root of 49, okay? So you have there.
Yes.
49 made it easier.
You arrive at that point. So now you let's say t is equal to 13 plus or minus 7 over 2. Okay. So now, you now have 13 plus 7 over 2 is 10. You can have a t is equal to 10. 13 minus 7 is 6 divided by 2. You'll have a t equal to 3. But we said your answer should just be t is equal to 3 because this model is only for days 1 to 6. Another model they will be doing for more than 6 days. But this is very specific for days 1 to 6. All right, so that's a quadratic formula. And so now at least you've learned how to do by factoring, by square root property, by completing the squares and quadratic formula. Right. So I think that one is yeah, so appreciating our quadratic formula. All right. So just a few more types of equation besides we learned linear, we learned quadratic. Let's now talk about absolute value equation. So I'm just reminding ourselves, we have talked about absolute value already when we were dealing with distance formula. And of course, we said that an absolute value is always positive. Just
Yes,
like when
yes.
we talk about absolute truth, all right? In whatever situation, whether the situation is positive or negative, the absolute truth remains to be positive. So that's absolute value. So yeah, we had this definition already before. So what we just want to learn now is to learn how to find solutions to absolute value equations. Right. This one is a simple one. We just need to understand the concept that for absolute value, if I go back to this, it is telling us that the absolute value of x is positive x if x is positive. But it is minus x if x is less than 0, because we're now saying minus of the minus x. All right. So the reason why that is minus x is if x is negative, the absolute value is the minus of that x, and therefore that is still positive. So that's the meaning, because sometimes you say, what is the absolute value minus x? No, the absolute value is minus x if x is negative. So negative times negative becomes positive. So I just want to emphasize that explanation. So now it's important to know this concept so that you do not solve if you know there is no solution. So it says if you have an absolute value of ax plus b is equal to c. If your c is less than 0, which is negative, you have no solution because the absolute value can never be negative. If c is equal to 0, yeah, absolute value of ax plus b is equal to 0, then you just have ax plus b is equal to 0, you'll have one solution. But if your c is greater than 0, you will have two solutions because you will have to equate your ax plus b to a c and a negative c. Okay, so anyway, that one will be clear as we move on. So look at the problem. If it's your c is negative, immediately say no solution. And then if it's 0, then solve for your x. If your c is greater than 0, you'll solve for your x, but you know there will be two solutions. Okay. So just some examples here. If I have 3x plus 4, absolute value is equal to negative 9, you know that you say, well, no solution immediately because you have a negative c. Okay. But if equal to 0, you just set it to 0. So you remove the absolute value sign, and you say, now say minus 5x plus 10 is equal to 0, and therefore x is equal to 2. That's one solution. So I'm just giving some illustrations. However, if the value of your c is greater than 0, then you will have to do two things. Okay, so I have that equation there. The absolute value of 5 minus 2x minus 11 is equal to 0. All right, make sure that you make that of this form where your constant is at the right side. So transfer that to the other side, that's greater than 0. Then you split the equation into two separate equations. You remove the absolute value sign, equate to positive. Similarly, removing the absolute value sign, then equate it to negative. Because we say that that value inside there is either a negative or a positive, but of course the answer finally is 0, or is positive. So that's it. So remove the absolute value sign, equate to its positive value, remove the absolute value sign, change it to its negative value, and solve for x. So therefore, one answer is -3. The answer is 8. Let us check whether that is correct. All right. So if x is -3, 5 minus 2 times -3 is 5 plus 6, which is 11, minus 11 is equal to 0. If x is 8, 5 minus 2 times -8 is -16. Plus 5 is -11, and the absolute value of -11 is +11. So there will be 2 answers for this equation. So just to remember, you isolate the absolute value, split the equation into 2 separate equations, remove the absolute value sign, equate it to the positive c, and then the second one is equate it to its negative c. So with that, let's try solving. So just we just remember the, okay. So I am just giving those with greater than 0 so that, you know, you really can practice the splitting. All right, so let's do together number 1. So we say the absolute value of 6x. Okay, let me not, why do I have to, okay, all right. So we'll split it into 2, okay, because it's already isolated. So we now say 6x plus 4 is equal to 8. The other one is 6x plus 4 is equal to -8. And then solve for x.
X equals to 4 over 6.
All right. So 6x is equal to 8 minus 4 is 4. One answer is 4 over 6. But simplify that. That is 2 over 3, right? The other is 6x plus is equal to, okay, 6x is equal to minus 8 minus 4 is minus 12. X will be equal to -2. So there will be 2 answers. So you can substitute if you wish to check whether your answers are correct. So 6 times -2 is -12 plus 4 is -8. Absolute value of -8 is 8. The other is 6 times 2/3 is 4 plus 4 is 8. So therefore, okay. Do 2 and 3 so that after that we can proceed.
X equals to 1, X equals to 5. 5 and 1. Together.
For number 2,
X
I
equals to
got x
5.
equals 5 and x equals
X
negative
equals
5
3.
over 3.
Yeah, that's what I.
Equals X.
Yeah. So of course you transform that to the absolute value of 3x minus 5 is equal to 10, right?
Mm-hmm.
For that number
Yeah.
two. Yes.
Okay, so funny.
So, okay. So you say 3x minus 5 is equal to 10. The other one is 3x minus 5 is equal to minus 10, right?
Mm.
We're so unsure.
So we have 3x is equal to 15. So x is equal to 3.
Mm-hmm.
3x is equal to minus 5. If I transfer 5 minus 5 to the other side, x is equal to minus 5/3. You need to be careful. I know some would just, you plugged in things that may not have been, or maybe instead of a plus, you put a minus. So your answer should be 3 and negative 5/3 for number 2.
Uh,
Or are you
5
doing number 3, Sine?
is 15 divided by 3 is
thought-
5.
Yeah,
Oh.
15 is 5.
A 5. Why did I put a 3? Okay, sorry, that should be a 5. Tell you. Okay. Why did I put a... Okay, it's 5. But 3 is a 5. So 5 and negative 5/3. Okay, do number 3. And I think that one, that's the only, you're using the same principle for equations, linear equation. The only thing is you're adding the concept of splitting it into two types of equations, where one is a positive C and the other one is a negative C.
-1
Okay, and
by 3/2.
minus or
Oh.
plus?
It's 1.
Is it not minus 1?
-1 and -3 halves.
And 3/2.
You put -1.
Positive 3/2.
Yeah, it's minus
Positive
1.
3
Yes.
1.5.
Okay. Yeah. So just to put it on record, have the absolute value of 1 minus 4x is equal to positive 5, 13 minus 8. So you have 1 minus 4x is equal to 5. 1 minus 4x is equal to minus 5. Minus 4x is equal to 4. So x is equal to -1. Minus 4x is equal to -6. So x is equal to -3. Positive. 3/2.
Mhm.
So -1 and 3/2. Is that easy?
It's
Yes, it
Yes.
is. We wish we can just have all absolute value equations, all right? So the last type of equation we will be talking about would be, it's not really equations. We call it inequalities. Okay. So we also have inequalities in math, of course. It's not always equal. And even in life, not everything would be equal. There are inequalities. So with the symbol not equal to, we have the symbol greater than, we have the symbol less than, or less than, or equal to, greater than, or equal to. So just be very familiar with our symbols, okay? And so we can also, just to illustrate the less than, greater than, less than or equal, greater than or equal in a number line. So maybe you have, yeah, in the past, we say when you say less than, it's from a certain, if say x is less than 1, it's from this point to the left up to the negative infinity. But then you need to put a what's that? Circle to say that 1 is not included. So just the same, if you say x is greater than 1, it is from that 1 to positive infinity, but then you'll have to put that circle to show that 1 is not included. But if you say less than or equal to, you have to shade the circle to show that 1 is included. And similarly, when you now have greater than or equal to, we shade the circle so that we show that the value is included. So those are some illustrations of how we put that in a graph for our inequalities. Okay. And we can also use set builder notation. Right. So yeah, these are just some symbols. Okay, so set builder notation is when you put the it says x, we say this as x less than b greater than a. But in our situation, I would always want to use the interval notation. It's easier to do that than the set builder notation. So if I now have your x is between a and b, you use a parenthesis. Where a, without the equality, we just use a parenthesis. So that is from a to b. That's what it means. If you now say x is greater than a, then there is no equality there. You use that parenthesis there, and because it's greater, that is up to infinity, positive. If x is less than b, you say it's from negative infinity to b, but b is not included, so we use the parenthesis. However, if we have greater than or equal to a, we use a bracket to show that a is included up to positive infinity. Similarly, x is less than or equal to b, that's negative infinity to b, and use a bracket. B is included. If you say x is between a, where a is included, but b is not included, then we now use a bracket here to show that a is included, parenthesis there to show that b is not included. Okay, so just the same here. Because b is included, but a is not, parenthesis, bracket. So, okay, and then when we now say a and b are included in that interval, then we use bracket for both. If we're using or, then we now use union. Okay, although we're just making ourselves familiar with some of the notations. But if you're dealing with all real numbers, then it will just be negative infinity and positive infinity. So these are some ways of expressing solutions of inequalities. Okay, now, to solve for inequalities, we need to use some properties. And one property is called addition property. An addition property means that if A is less than B, if you add a constant to one side and do the same addition on the other side, the inequality remains the same. So it's just the same as equality. You add the same constant to both sides, the inequality remains the same. So even if you say A is greater than B, you add C and another C, it will remain to be greater. But please note of this, for multiplication property, if you multiply both sides by a positive number, the inequality sign remains the same. But if you multiply both sides of the inequality by a negative number, and I think you know that the inequality will change. And therefore, that less becomes greater. So let me just give an illustration on that. Why is that so? Okay. if I say, you know that 2 is less than 5. If I multiply 2 by 3, that's 6. 5 by 3, that is 15. It is still less than. But if I multiply both sides by -1, just suppose. So I multiply -2 by -1, that becomes -2. 5 by -1, that will become -5. What will happen now to the inequality? -2 is now greater than -5. And I think you know that in the number line, that is 0, -1, -2, and so on. So -2 is greater than -5. So whenever you multiply by a negative number, both sides of inequality, then the sign of your inequality will be reversed from greater to less or less to greater. So with these principles, we just have to solve a few inequalities, and then we'll move on to the next chapter. So like here, I now have 2x plus 1 is less than 9. Okay. So
Okay.
2x, you transfer, you add, this is addition, okay? So you subtract 2x less than 8. Of course, your answer there for x is 4. All right. Okay. So 2x is less than 4. So you have to substitute values. All values that are less than 4 will be an answer to this problem. And so if you want to put that in an interval notation, how do I put it for your final answer? So x less than 4 is written to be minus infinity to 4. But because 4 is not included, I will have to put parentheses. So x less than 4 is written as negative infinity to 4. So for the other example, 1 minus 2x is less than 9. So minus 2x is less than 8. So I divide both sides by -2. Because I'm dividing by -2, I will have to change the sign of inequality. So your answer will be x. Instead of less, will become greater than -4. And to write that in interval notation, you say, because it's greater than -4, you know, say it's from -4 to positive infinity. -4 to positive infinity. This one denotes that it's greater than -4. Right. Okay, so just these simple problems here. Let's solve these inequalities. And we want our answers to be written in interval notation. Kindly do that. So we use the same principle for equality, except for that greater or less.
Yay!
Yeah.
Ito lang.
Yeah.
Yeah, that one is actually you can use your mental math, and then it's just important to know how to write the equation in interval, the answers to be interval notation.
So it's
Mental math, what's your answer?
it's bracket
Okay, so to begin with, okay, anyway, what will be the answer? X is what? Greater than
X.
or equal to? The answer first, before the bracket, okay? X is
Okay.
greater than or equal to, what's your answer?
-5.
-5.
Okay. So 4x minus 2x is 2x. Minus 3 minus 7 is minus 10. So it will now be minus 5. And of course, your answer, final answer will be bracket greater. That's greater. So you begin with minus 5 Positive infinity. But for infinity, you always use parentheses. So if it's greater, you begin with that number. And then put infinity. If it is less, you begin with negative infinity, then that number. So I hope you see the relation.
The parenthesis, this
So
square.
minus 5, so positive infinity. Okay. How about number 2?
Huh?
Question says, so it's 2x greater than or
Oh,
equal
if
to
it's
minus 10, right?
equals to.
But how did you get x is greater than or equal to minus 5? You
Because-
divided both sides by 2.
Yeah.
So doesn't that doesn't change the equality sign?
Mm-mm.
Division.
If it was
It's a
Uh,
positive, okay?
negative 2, it would
It
change
doesn't, it doesn't change.
Ah,
But because it's positive, it doesn't.
but there is a negative on the other side.
Yeah,
There
but
was
you're doing it by negative.
Always put the x to the other side. To the left-hand side. So 2x is greater than or equal to minus 10. You're dividing by a positive 2. You only change if you're dividing by a negative value.
Oh. I mean, you wouldn't divide by negative.
No, it doesn't matter.
For number 2.
One.
Okay? It is greater or less? Yeah, it's important to say whether it's greater or less now that we are dealing with inequalities. If it were equality, you can just say 1, 2, whatever. But here, be very specific with the inequality sign.
X is less than or equal to 1.
All right. Yeah, because from there, you got minus 17x is greater than or equal to minus 17. But because we're dividing by negative 17, then the sign of inequality will change. And I said, if it is less, begin with negative infinity and end with that 1. But because 1 is included, we put a bracket. So minus 8, 1.
How do you know when something is included and not?
What's that question, Sneh?
If it's equal to. So if it's just less than, then it's not included. But if it's
Oh,
less
yeah.
than 2, then it's included.
So that one, if there is an equal, that one at the line. So, have less than, greater than, less than or equal to, greater than or equal to. Okay. Number 3. Minus x plus 4 less than 1/2 x plus 1.
I got x is greater than 2.
Okay. So in interval notation, it is written as,
To infinity.
okay, but we use the,
Parent
we talk of bracket or parenthesis. So we'll be using
parenthesis.
parenthesis. Okay, so does everyone, did you get greater than 2?
Yeah.
Yes.
The infinity
Yes.
sign.
As for the record, minus x minus 1 over 2x is greater, sorry, less than, I am used to, okay.
I thought x is greater than. Did you?
Mhm. Minus x minus 1/2 x is less than 1 minus 4, right? So the minus x minus 1/2 x is minus 1 and 1/2 or 3 over 2x less
Mhm.
than minus 3.
3.
Okay. Multiply both sides by 2. So I will have minus 3x is less than minus 6. Divide both sides by negative 3 greater than 2. And so your answer should be written as, because it's greater, begin with that number and end with a positive infinity.
Yeah.
So yes, those are inequalities. Yes, so far we learned all equations and inequalities. And so the next things we'll be doing in the next 30 minutes will be something much lighter in the head, okay? Because I want to just introduce the functions, which will be what we will be dealing with until the end. Is everything. I'll just introduce different kinds of functions. So at the beginning, as Manesh prayed that please help us so that we'll always be ready with for the quiz. Well, we'll have a short quiz on Tuesday at the beginning of the class, the first hour. All right, and oh, I think you'll have another long weekend. Yeah, because it's President's Day on Monday. So you'll have enough time. So I'll not give any homework for this time except for you preparing. And that's just the models, okay, from the linear models until inequalities. All right, so as I promised, I will be giving you, for the linear models, very similar problems to what we have discussed in class. So that your mind will not be, oh, yeah. So just be familiar with how to deal with investments, with plans in a company, whatever is that. Okay, a little bit of distance. Yeah, and maybe age or number problems, something like that. But then all the rest will be solving equations, quadratic equations by factoring, by zero property, by completing the squares and your quadratic formula, and the absolute value equations and inequalities. Okay,
The
so
quiz
yes.
will have more of the word problem.
No, not very. No, I won't give too many. I don't want your mind to be. I will not very many. Okay, maybe. Yeah, except for this, I'll give some samples of, find
Which
I think we only discussed a few things, yeah, in the word problems. And maybe what I'll do is, even for the quadratic formula, I will just ask you to, I'll only give one problem using quadratic formula, which is a real world. Okay, but all the rest, just one each. One problem each
Be
time.
equal screen like you did last time.
Huh?
Will you have the formulas on the screen like you
I
did last
will
time?
provide, yes. And by the way, even some properties. Yeah, I will be doing that. Okay. I'll provide those so that you will be reminded. There, we're now moving on to, imagine we're just in chapter 3, we're almost just a few more weeks. But don't worry, all the rest I will be discussing just introducing all the other functions, okay? But so that you get all the ideas before the as you finish your college algebra. So now for chapter 3, we will be talking about functions. Okay, you have heard about functions previously, and even when we were dealing with equations here, they are very much like the linear equation can be transformed to a linear function, quadratic equation as a quadratic function. Absolute value is actually an absolute value function. Okay, so we're talking of functions. So let's try to understand what functions are. But before dealing with functions, let me consider the mother of functions. And we need to know what functions are anyway. Functions are actually relations, relationships. This world is about relationships. And this is the reason why mathematics is very, very important in life, because math describes relations or relationships, just as life is about relationship. So it's just ordered pairs, the way we did previously when we were graphing. So relation is ordered pairs. And I think we know that in the ordered pair, the first value there is called the domain. And the second value in the ordered pair is called the range. Okay, so that's it. So if you have a set of ordered pairs and we want to look for the domain, just put all the first numbers, the first component of the ordered pair. So the domain would be 1, 2, 3, 4, 5. And therefore the range will be 2, 4, 6, 8, 10. And so the domain is called the input, the one that you are putting in a function. And the output is your range. So those are some terminologies. It's good to remember those, because as you know that whenever I give during the final exam, I will be having multiple choice. So this terminologies are very important. So the domain is the input, and the range is the output of value. Right. So, well, I know that you're visiting the website. So all of these are you have all of the PowerPoint presentations there, as well as our recording. So I'm glad that you are using the website. That I hope it helps you. The rolltech.net to remind you of what we have discussed so far. Okay. All right. Here. So relations, you are able to present that in ordered pairs. Or like what we did in our graphing, you can also have that in a table, all right? So the input value is your X, the output value is your Y. So we really, in general, the domain is X, which is the independent variable, and your range is the Y. Or you can put it in a graph, all right? So just from the graphs, we are able to find the ordered pairs, or we call it mapping. All right. So the mapping, this mapping here, yeah, where one value is associated with the other value. So your X is associated with a Y. So these are 4 ways of representing relations, ordered pairs, put that in a table, or in a graph, or in a mapping diagram. All right, so now, so let's move on to functions. So I said relations is the mother, and because it's the bigger set, and under the relations we have functions. Now there is a restriction for functions. It says that a function is a relation in which its possible input value will lead to exactly one output value. So one input should only be to one output. That's function. Or in other words, we're saying that your domain in a function should really be unique. I mean, you don't repeat the domain. The domain should be unique numbers. So if you want to determine whether the relationship is a function, you should know what are the input values or the domain. then what are the output values, which are the range? And if one input value leads to only one output value, it is a function. But if one input value will lead to two or more outputs, so which means that there's one input, there are two outputs, then that means that that is not a function. Okay, so maybe it's better to have some examples so that we could understand whether, all right, so let's look at this mapping. Okay, so you notice that in the first one here, this is a function because its input is associated with only one output. And because here, the four inputs would be to 4 different outputs, we call this function as 1-to-1. One input to one output. Now, there is also a chance where you have these different inputs, okay? But your output, like here, 0-to-0, 1-to-1, 2-to-4, -2-to-4, where we now have 2 inputs to 1 output. That is considered still a function because your domain would be unique. It is not repeating, although it can move to to one output, 2 inputs to one output. But at least we know that 2 is only associated with 4 and -2 is associated with 4. So you can have more outputs as long as your input will only be 1. We call this many to 1. However, if we have a 1 to many, in other words, this input 9 is associated with 2 outputs. All right? So in other words, 9 is repeated. You have 9, 3, 9 minus 3. It's not unique. There are 4 and there are 1, 9, 9, 0. So 9 and 9 would be repeated. Is not considered a function. We call this 1 to many. But most of all, if you have many to many, all right? In other words, you now have 1, 4, 2, 4, 3, 5, 3, 6. You're repeating the input. That will not be a function. So 1 to 1, many to 1 would be functions. 1 to many would just be relations and they are not functions. Okay. So maybe let's have some examples of this later on. So that's how it is. And one very important statement there is every function is a relation because the relation is the bigger set, but not all relations are functions. There are relations that are outside the circle of the function. So every function is a relation, but not all relations are functions. Okay, please remember that statement. So let's have an example to understand what we mean by function. So like even not only in a class of math, but in other classes, you know that the way the grading system is done is you have a certain percentage that would be associated to a specific GPA. So maybe in this class or in a certain university or college, if you get a percentage of 0 to 56%, the GPA is 0, which is a failure, F. 57 to 61%, it will be a 1, okay? Whatever is that GPA, it can be a D+, but I'm not sure about how it is done. But the way it is in that class, it says 62 to 66%, the GPA is 1.5, and so on and so forth. And 92 to 100, which is an A, is a 4. So the question that is asked is grade point average a function of the percent grade? Okay, so let's understand the terminology here. Let me write my pen. Okay. So is grade point average a function of the percent grade? In this question, which is the output, which is the input? Is the GPA the output or the input?
So
The output.
output.
All right. Is grade point average a function of percent grade? The word a function of is like the same as dependent on. Okay? So it's the same as saying is grade point average dependent on the percent grade. And therefore, the grade point average is your output because that's the one that depends on the percent grade which we consider your X. Okay, so is grade point average a function of the percent grade? My question is, if the input is percent and the output is grade point average, is that a function? That's actually the question.
Mm.
Your input is the percent.
Yes.
Okay, why is it a function, Bethany? Yeah, you are correct.
Because it's many to one.
All right. In other words, there will be, 0 is associated with 0. 56 is associated with 0. But just the same, your inputs would be unique. You are correct. So therefore, we now say yes, the grade point average is a function of the percent grade. Now, how about, is the percent grade a function of the grade point average? In other words, this is now our output. This is our input.
No.
Is that a function?
No.
Okay. Yeah, because it is what? What kind
One
of? It is?
one too many.
One too many. All right. In other words, your grade point average is associated with so many percentages. And therefore, the percent grade is not a function of the grade point average. So that's just to help us understand what are relations and what are functions. So maybe we can have some examples in life that would be considered to be one-to-one or one-to-many kinds of functions, all right? And I think you know that an ID, you will only have one ID for one student, right? So we call it one-to-one. Or a mouse, for a computer, you don't use two mouse to use. You just have to use one mouse for the computer because otherwise it will be difficult when you have two mouse. But one mouse to a computer, keyboard for a computer, key to a padlock. All right. In other words, the same key pattern. A man to a woman. So that one is about God's creation. Only a man, for married couples, of course, one man to one woman. So it's a one-to-one. It cannot even be one-to-many, okay? One-to-one. A case to a cell phone. Yeah, your one case to one cell phone. And of course, a shirt to whatever you have worn. But for a one-to-many, parent-child relationships. Because one parent, you have many children. But that is still a function. Teacher-student relationships. I am your teacher. I am relating with 4 students. Or a doctor-patient relationship. So one doctor with the different patients. The book author and books written. Okay, with several written books, but again, just one author. And car manufacturer and car models. All right. So let's now have a function notation here, which is what we will be using, where we say that y is a function of x. And in this case, our x is the independent variable and our y is the dependent variable. So the value of y depends on the value of x. And so previously, we learned in our previous discussion on algebraic expressions, if you remember, we tried to evaluate algebraic expressions when setting x to a certain value. So it's actually the same as evaluating or solving functions, where we say that if I have f of x is equal to x squared plus 3x minus 4. And if I say f of 2, it means that I substitute 2 for every value of x. So it will now be 2 squared plus 3 times 2 minus 4. Well, of course, 4 plus 6 minus 4 is 6. Right? So instead of saying evaluate x squared plus 3x minus 4 at x is equal to 2. What we will just put there is that if this is your f of x, what is f of 2? And you know that you will just substitute. So for letter B, just tell me the answer for your f of A. What will be your f of A? Okay, everyone, I just want everyone to talk.
A squared
A
plus
squared
plus
plus 3a, correct? Minus 4. That's f of A. How about f of A plus h?
Oh,
A plus H squared
That will now be A plus h squared plus 3a plus h plus 4. Simplify. Oh, everyone, so that we are reminded with how we square and simplify this and give me the final answer.
is it not -4?
Up. So I am also like, sometimes I would say be very careful with small things, but I also make mistakes put in. Okay, thank you. Okay, so oh, you can give me the squaring and so on. Yeah. So if I square a plus h, what will it be?
A
Say you square. Okay, a squared
plus
plus
2ah
2ah, yes. Plus
x
8.
squared.
That's squaring a binomial. Plus 3a minus
3a
plus 3h
minus
minus. Final answer.
a
Is that the
squared
final answer? Is there anything that we will have to combine?
no
Yeah, so a squared, h squared, they are all different, right?
different.
Yes.
Nothing.
So that will already be, you are not combining anything anymore. Okay. Oh, letter D is nice. You know already f of A and you know f of A plus H. 5A, H. Oh, no, you can combine. This is 3A. What is that now? Where is it? Okay, yeah. Okay, combine f of A plus H. I mean, do f of A plus H minus f of A over H.
Okay.
I think we
A
can combine 2AH and this is 3A. What do I have? Ah, that's okay. Yeah.
no. It's a
squared
plus h squared. No. Yeah.
Yeah, put this together. You already know your f of A. You know your f of A plus H. Put them. Okay, do it. Yeah, okay. You want to do it mental math?
It will be hard.
Okay.
No.
You know this to be your f of A. You know this to be your f of A plus H. So you subtract f of A plus H minus f of A and then divide by H. It's hard to do mental. Subtracting. So what will it be? Oh, you need a pen. Okay. And a pen and a paper. So a squared minus a squared, that's gone. 3a minus 3a, that's gone.
Yes,
And 4, that's gone. What remains?
it's 2AH. No, it's H squared plus 2AH
Okay, 8 squared plus 2AH.
plus 3H
Okay, over.
over H.
All right. Now, so you notice that if I subtract, this will be out.
Yes.
3A will be out. 4 and 4 will be out. Okay. So you now have 8 squared plus 2AH plus 3H over H. And then what do?
You take out one factor, which is
All
A.
right. So you now have 2AH plus I just will rearrange later on plus 3H over H. But H is common. So finally you'll have
H
2A.
plus A.
Okay, you want to begin with an H, which is okay, which is good. All right. But it can be 2AH, no problem there. Okay. So you 2A, then that will become H plus 3. Is that it?
Mm.
Yeah.
Yes.
Yes. So divide everything by 8. So 2A plus H plus 3.
Yeah.
All right. So it's just like what we have done previously. Okay. Just for the sake of evaluating and solving, and then that will be it for do all of this. F of negative 3, F of A minus H, and F of X minus F of A over X minus A.
Oh.
I think for letter A, you can just do mental math there.
Yes. Minus 11. Minus
Good.
11. Minus 11.
Okay, good.
Then number
And that
2.
one, again, you can do mental math.
2A minus 2A minus 5.
Okay. 2A minus 2H minus 5. Good. Letter C.
S minus S Q over S minus Q.
For C, I got A and B.
That's what's there.
Completely lost.
What is it? 2X?
No, minus 5 is what?
minus 5 is minus 10.
Yes. What is that?
I got 2X
It's minus 5. Minus 5 minus 5 or minus 5 plus 5?
It should be 5 minus 5. 2x minus 5.
Instead of you have 2x minus 5 minus 2a minus 5.
Oh,
Right?
okay. So
Yeah.
So it will be 2x minus 5 plus 5 is minus 2x minus 2a. Over, of course, there's an over there, over x minus a.
Yeah.
Final
It will be,
answer.
the answer is 2.
Yes? The answer is
Two.
2. Don't hesitate.
how?
Common is 2. X
Yes.
minus a over x minus a, right?
Oh, yes. See, I was-
Oh, yes. So that will be equal to 2. As long as you should say that x minus a should not be equal to 0 because you cannot divide. You cannot divide by 0.
I was
What
in this.
happened, Manish?
I was trying to. I knew there is a common because it looks very common.
Yeah.
Something could be extracted out.
What
Yes.
was it?
I was trying to variables out.
Oh, you were trying to look for the variable instead of for the constant. Okay. All right. So, we will be dealing with all the functions just to give you some other types of functions, okay? And then we'll end here. We now have a certain constant function. If your function is f of x is equal to c, it means it's constant, all right? Because for all input values, you only have one constant. And so this one is the way we put the graph of a constant function. Okay. Now there's another kind of function we call identity function. Right? When you have f of x is equal to x. Where your domain would be all in negative infinity, negative infinity, and positive infinity for the range. And so it will be a straight line. Okay? Passing through the origin. We call that identity function. And I think previously we learned this too, the absolute value function. I think I already showed this to you previously. That is the picture of an absolute value function. And we learned about our quadratic, right? Quadratic equations. So there is also what we call a quadratic function. And you know the picture of a quadratic function? What's the graph of a quadratic function?
Parabola.
Yes, it is a parabola, a very nice kind of function which is very symmetric to its certain it can be in an origin if it is f of x is equal to x squared. Or yeah, there's a line to which it is symmetric. So these are some of the functions, but we'll have more besides
Why is
absolute value in yes.
why is quadratic function x squared?
Yes. So whenever you have an x squared, so
It's
it can
equal to,
just not be x squared. It can be x squared plus 2x plus 3. That will still be a parabola. But it will just shift its line of symmetry to a certain point. Okay? So here, if it is f of x squared, f of x is equal to x squared, it will be like that. But you know, if f of x is equal to minus x squared, how will it look like?
Downward.
Yes, it will open downward. Yeah. So we'll talk more of these types of functions in our discussion here after, of course, our short quiz on Tuesday. So please just note that, yeah, prepare for the quiz, and I think you will be fine. So yeah, because you're preparing for a quiz, I want to pray for you before we leave. Let's bow our heads. Heavenly Father, thank you so much for being with us this whole time of our class discussion. We always depend upon you. And so, Father, please just guide us that indeed you are always our input. Anything that you do for us is always for our own good. And so, Father, kindly guide these students as they go about their day's activities today. They will also be preparing for their short quiz on Tuesday. And you know how much I pray for them. They are always in my prayers. And so just at this time, I leave them up to you. Please be their guide. Help them to completely trust you. And always remember that you always want the best for them. Keep us all in the hollow of your hands today. We pray in Jesus' name. Amen. Okay, so have a good week ahead of you.
Thank
Thank you.
you. You too.
Okay. Yeah. Let me